Okay, so in this question, we're given a function f of x, which is a cubic, and we need to find the stationary points of this cubic and determine whether they're maximums or minimums, and we need to use the second derivative test to do that. Okay, so to begin, to find the stationary points, we first differentiate. So we get f dash of x equals 6x squared minus 18x minus 60, and we set this equal to 0 and we solve this equation. So I think we can divide everything by 6 first of all, so we get x squared minus 3x minus 10 equals 0, and we can factorize this. So we get x minus 5 and x plus 2, and that equals 0. So if we solve this, we get x equals 5 and minus 2. So these are the two x coordinates for the stationary points. And the first thing we'll do, we'll get the corresponding y coordinates. So we'll substitute these into the original function. So we have f of 5 equals, so that's 2 times 5 cubed minus 9 times 5 squared minus 60 times 5 plus 24. And if we use calculator for that, that equals minus 251. And if we substitute minus 2 into the function, and again if we use calculator, that equals 92. So we have two stationary coordinates. We have the coordinate 5 minus 251 and minus 2, 92. Okay, so we now need to work out whether they're local maximums or local minimums, and for that we're going to do the second derivative. So we'll differentiate the first derivative to get f double dash of x. So that gives us a 12x. That's minus 18, and this becomes a 0. And now that we've got the second derivative, we're now going to substitute the 2x coordinates in. So this is our x and y coordinates. So if we substitute the first x coordinate in, so f double dash of 5, so that's 12 times 5 minus 18, that equals positive 42. So that's bigger than 0. So therefore, this stationary point, 5 minus 251, is a local minimum. So if it's positive, it's a minimum. And if we substitute the second x coordinate, minus 2, we get 12 times minus 2 minus 18, and that equals minus 42, which is negative. So therefore, 2 minus 2, 92, that's a local maximum.